Humans have been counting for a long time. To do so, we use systems that relate unique symbols to specific values. This is called a number system, and it is the technique that we use to represent and manipulate numbers. Computers use their own number system, which is called the binary system, allowing them to encode information, perform arithmetic operations, and execute logical control processes. Before we learn more about the binary number system, we will look in more detail at our normal decimal numbering system. First, let's start with a simple question. Why do we count the way we do? Any numbers that come after that are the same with an additional or different digit placed to the left? Why don't we count differently? It seems a completely arbitrary choice initially. One possible reason is the number of fingers on our hands. We have 10 fingers on our hands, so our number system developed the way it did. Therefore, our decimal system uses 10 as a base and the numbers range from 0 to 9. Let's look the 3-digit number 129. This is made up of 100 plus 20 plus 9. If we look at the diagram, we see that as we move from right to left the columns increase by a factor of 10. The 2 in the second column isn't 2 but is 2 times 10 equals 20, and the 1 in the third column isn't 1 but 1 times 10 equals 100. The first column is 10 raised to the power of 0. This is equal to 1 and represents our units column. A computer uses bits to represent information. A bit is the most basic unit of storage in a computer. An essential component of computers is called the transistor. Just like a light switch, the transistor either allows or prevents current to flow. So, it only has two states, on and off. Every number in a computer is an electrical signal. In the early days of computers, electrical signals were representing with an on state, a negative charge, and an off state, a positive charge. This forms a kind of binary switch. These two states can be represented using one of two symbols, 1 and 0. This means that the binary number system has a base of 2. Only two symbols are needed to represent every number. Instead of representing numbers as individual units, like the number 10 or 400, we use groups of ones and zeros. For example, here is what it looks like when a computer counts from 0 to 10. This is called the binary number system. Each binary digit is referred to as a bit. For instance, 0110 is composed of 4 bits which are 0, 1, 1, and 0. When it comes to placing values to the bits, digits, in this system, we place values corresponding to ascending powers of 2 from right to left. The rightmost bit is called the least significant bit, LSB, and the leftmost bit is the most significant bit, MSB. You can manipulate bits left and right with bitwise operators to efficiently change the value of a number at the machine code level. And here is an example of how to calculate the corresponding decimal number from a binary number.